Hey everyone, so I'm going to do another example of solving rational equations. This time one of the terms doesn't even have a visible denominator, but we're going to follow through with the same steps. So again, step 1 is to factor. Here we don't need to factor, and step 2 is to find the common LCD. So let's work on that. So we have x plus 7 in as one of the denominators in the first term, and this term, this 5, doesn't have a denominator, but we can turn this 5 into a fraction by putting it over 1. So now 1 is in the denominator, and this term has an x. So our LCD is going to be a combination of that. Anything times 1 is itself, so I'm not even going to include it in the denominator. So our denominator is going to be x, then x plus 7. And again, when you're trying to get all the denominators to be the same, you're only going to multiply by what's missing. So what's missing from this term out of the LCD, right, the least common denominator, that's going to be the x. It already has the x plus 7. So you're going to multiply x and x on the top and bottom. Now the 5 over 1, on the other hand, is missing everything. So you're going to multiply by everything. You're going to multiply by the x plus 7 on the top and the bottom. And then for this last term, what is it missing? Only the x plus 7. So multiply that on the top and the bottom. Alright then, so when we do that, don't distribute anything yet. You want to do that pretty much later on. If you distribute mid-solution, you're going to most likely end up confusing yourself with what needs to be canceled out or simplified, and it's just going to have you repeat steps or do more steps than you really need to. So be a bit conscious of when you need to distribute and when not to. This is going to be 5 times x, and then left over with the x plus 7, and then x over there, and then this is equals to 3x plus 7 over x plus 7. Alright, and like I said in the previous video, once you get all the denominators the same for every term, right? This didn't have a denominator visibly. We had to make it that way. But once it's that way for every term, then you can definitely just cross it out. I'm doing a little fancier cross out this time. A little squiggle. Alright, so we're going to end up with x, 3x plus 25. Just everything in the numerator is what you work with moving forward. X plus 7. Oh, and just a reminder, the goal is to solve for x. Just keep that in mind. Equals 3 parentheses x plus 7. So now you're just going to simplify. So that's going to be distributing combined like terms. You're going to end up with 3x squared plus 25x, right? Distributing that to both of these, distributing this to both of these. Make sure you keep track of the change in sign. So negative 5x times x, that's negative 5x squared. Negative 5x plus 7, that's negative 35x, equals, and then 3x plus 21. Again, we want to combine like terms, so 3x squared and negative 5x squared, that's negative 2x squared. We have 25x and negative 35x, that's negative 10x. And then we still have 3x plus 21 on the other side. Now I want to have a positive x squared term. It'll just make dealing with solving for x, I feel, just a bit easier. The signs aren't really a big deal for some people, but I know for others they are a big deal. So if you have trouble keeping track of your signs, I advise you to try and make your leading term the positive value, and the others just whatever signs they are. So I'm going to move these terms to this side, move all the left terms to the right side so that this can be positive. So I'm going to add 10x. I'm going to add 2x squared. I'll just put it over here. Because there's no term that I can combine it with. But when I'm done with everything, it will be the leading term. So this is just 0 because everything cancels out. So 0 equals, it's going to be 2x squared plus 10 and 3 is 13x, and then plus 21. Okay, so now it's time to factor this. And the reason why we're factoring this is because this is a quadratic equation and we're solving for x. So when we solve for x, we need to use one of our factoring methods, either the AC method or our regular traditional factoring methods, the quadratic formula, whatever is comfortable for you. I'm going to use the box method because that's what most of my videos in terms of factoring are based off of. But whatever factoring method you know of, please use it. If you're comfortable with another method besides the box method, that's totally fine. I did make a video on factoring by grouping as well within the same video of the box method. It's called factoring by the AC method. You can definitely watch that as well if the box method is something that you struggle with. So when you're setting up the box for factoring a trinomial, first term goes into the upper left, constant goes into the lower right, and because there is a non-1 value in front of the x squared term, AC implies multiplying a and c, right? So the a is the 2 and the c is the 21. 2 times 21, that's 42. Now you got to ask yourself what two numbers, when multiplied, gives you that 42, but when added, gives you the negative 13. That's going to end up being 7 and 6. Now, I'm sorry, not negative 13, positive 13. It's going to end up being 7 and 6, and because the product is positive and the sum is positive, these values are both going to be positive. So plus 7x plus 6x. All right, and then we're going to factor. So we're going to start off here. What can we factor out from these two terms? That's only going to be an x. What times x is 2x squared? That's just 2x. What times x is 7x? That's just plus 7. What times 2x is 6x? That's just plus 3. And we have our factors, which is x plus 3 from here, and then 2x plus 7 from here. Now, because we're solving for x, we need to set it equal to 0. And that means we just set these individual factors to 0. So x plus 3 equals 0 on one side, 2x plus 7 equals 0 on the other side. And then you just solve for x, so minus 3 minus 3. You get x equals negative 3. Boop. And then minus 7 minus 7. You get 2x equals negative 7. Divide everything by 2. You get x equals negative 7 over 2. Okay, so we have our two x values. But again, this is a rational equation, so we still want to check to see if any of them are extraneous. So let's see, when we get x equals negative 3, and we plug it into the denominator, well, negative 3 plus 7, that doesn't give me 0, that just gives me a non-zero number. So that means negative 3 is okay for this one. If we plug negative 3 into here, well, that's still okay. 3 divided by negative 3 is negative 1. So it doesn't affect the problem in a bad way. So this is actually a good solution. Negative 7 over 2, if I do x plus negative 7 over 2, that's fine. That's a non-zero number. That's a non-zero number. If I plug in negative 7 over 2 in here, that's fine as well. It's also a non-zero result. So this is good as well. So we can write no extraneous solutions, which is a good thing that we went over this example. In the previous example, there was an extraneous solution. In this example, there were no extraneous solutions. There are cases where you can get multiple x value solutions, and some of them could be extraneous and some of them could be fine. So just keep that in mind when you're solving for your x values for rational equations. And that's pretty much it. If you have any questions or concerns, leave them in the comment section below. Like and subscribe, share the video, and I'll make more for you guys later. Bye.